Hi everyone, this is Mr. Ruhoy, and this is an Algebra 2 video for solving rational equations by using the least common denominator, otherwise known as the LCD. So the LCD is a number or variable, or a combination of both, that can be divided evenly by all of the original denominators. And in these equations, we're dealing with fractions that all have denominators. The way we can solve these equations is by taking the LCD and multiplying both sides of the equation by whatever that works out to be. So let's take a look at this first example. We have 5 over x plus 7 over 4 equals negative 9 over x. Our first step is to multiply both sides of the equation by the LCD. So we can determine the LCD to be 4x. And the way you would figure that out is by taking all of the unique denominators. Because if you look at the denominators, we have an x, we have a 4, and we also have an x. So the unique denominators would be x and 4. And you can take x and 4 and multiply those together. That gives you 4x. So that's what we can multiply both sides of the equation by. If we were to do that, that means we have to distribute all the terms here. We have to use distribution, and that's what I have written here in our next step. So if we were to multiply these, what would happen is we would have these x's divide out, 4's divide out, and these x's divide out. And in our next step, I'm going to collect the remaining terms. We have the 4 times 5, that's 20. We would get 7x. And then negative 9 times 4, that's negative 36. And now this is a lot friendlier. We got rid of those fractions. Now we can do step 2, which is to combine like terms. Simplify, combine like terms, and then solve for x. So to do that, we would subtract 20 from both sides. We would divide both sides by 7. And you would see that x is equal to negative 8. And that was our goal. We wanted to solve for x. However, there's one more step that we have to do, and that's to check our solution or solutions by using the original equation, the very original equation. So we're going to take negative 8, and we're going to substitute that into the original equation, and you can see I wrote negative 8 in purple where x was in the original equation. Now that we substituted that in, we're going to have to simplify this equation a little bit. What I did was make this a little easier. I multiplied the numerator and denominator of this fraction 7 over 4 by 2. That created common denominators throughout. I also took the negative 9 over negative 8 and I just wrote that as a positive 9 over 8. And now we have all common denominators. So what we can do is we can take our numerators, negative 5, the 14, and 9, and write that as a separate equation by taking these up here. And that is a trick that you can do if the denominators are all the same in your equation. And finally, you can see that 9 is equal to 9, which confirms that negative 8 is a solution to this system, this equation. You always have to check your answers. You always have to check them to make sure they are correct. Because sometimes you can get extraneous solutions, which are algebraic solutions, but not graphical solutions to a system. All right, let's take a look at a second example I have here. Our example 2 would be 1 minus 8 over x minus 5 equal to 3 over x. So our first step is to multiply both sides of the equation by the least common denominator. And we can determine that by taking each of the unique denominators, which would be x and x minus 5, and multiplying those together. Now you really don't have to multiply them together. You can just write them next to each other, x times x minus 5. But that's what we're going to multiply both sides of our equation by. Now, if we're multiplying both sides of the equation by this LCD, we're going to have to use distribution. We're going to have to multiply both of these terms by x times x minus 5. this one as well. So in the next step here, I distributed. And now what happens is there are opportunities for terms to divide out. Have an x minus 5 and an x minus 5. Those divide out. You have an x and an x here. Those will divide out as well. And what's really nice about that step is that it eliminates all of the denominators. It gets rid of all the fractions. We're no longer dealing with fractions. And you can see the step here, I rewrote it without those divided out terms. Now we're going to have to do our next step, which is to combine like terms, simplify, combine like terms, and then solve for x. So that's what I began to do with this step here. I had to do some more distribution. That's where each of those terms came from. X times x was x squared. X times negative 5 was negative 5x. And then on the right side of the equation, we have 3 times x, which is 3x. And 3 times negative 5, that's negative 15. So doing this distribution really opens up the problem and allows us to combine like terms. And that's what I did with our next step here. I combined the negative 5x and negative 8x, and I subtracted 3x from both sides. That gave us negative 16x, combining all the x terms. And then I added 15 to both sides. So now everything is on the same side of the equation, set equal to 0. Anytime you see an x squared, that's what you want to do. Because x squared means that we're dealing with some type of quadratic expression, quadratic equation, where we're going to have to do some factoring. And this can be factored using the factors x minus 15 and x minus 1. Because negative 15 and negative 1 multiply to positive 15 and add up to negative 16. And now we can do a t-chart. Do a t-chart and we would get x equal to 15 and x equal to 1. However, it's not enough just to solve. We have to do our third step, which is to check our solution. In this case, our solution, that in here. We have to check both of our solutions, make sure that they work the original equation. And to make sure that they're not extraneous solutions. Again, extraneous solutions are solutions that you can arrive at algebraically, but may not be a graphical for your equation. So we're going to have to take this 15. We're going to have to substitute our original, which I showed here. You can see in purple, I replaced x with 15. 15 minus 5 gave us that 10. Then we have 1 minus 8 over 10 equal to 3 over 15. And if you look at these two equations, these two fractions, both of those can be simplified. They can be simplified to 4 over 5 and then 1 over 5. You can take 1 and rewrite that as 5 over 5. And very, very cleanly, you can see that 5 over 5 minus 4 over 5 is the same as 1/5. And that proves that this is a solution to our system, our equation. And it's not enough just to check one of our x's because we got 15 and we also got 1. We're going to have to take 1 and substitute it into our original equation as well. We have to check both of them. So you can see in purple, I replaced the x with 1. That gave me negative 4, which then that fraction became negative 2. And you can finally see that we get 3 equals 3, which confirms that 1 is one of our solutions. So both the 15 and the 1 work. Those are both solutions for this equation here. All right, I hope this video helped. Thank you for watching.